Hello and welcome to another video, this time going through the first 10 questions of Maths Specimen Paper 2, questions A to E. The reason why I'm doing the short little questions first is really just because I figured they'd be the easiest to do. I'll try and get as many as I can bumped up for whoever asked me as a request to go through the specimen paper, so I'll try and get the longer questions up. Somebody else recently asked me about questions 6 and 7, or the last questions on these papers, the map papers. That is something I've been meaning to do for quite some time, so I'll try and do that at some point as well, but all these things take time. I can probably, now I'm working again because I went back to work today, I can probably get through, I don't know, depending on how I feel, sort of like 3 or 4 questions a week I'll pop up, I mean of the longer type, of a long step question or math. Anyway, let's get on with it. So, first question, I'm looking at this. I mean, this is the thing with the specimen papers, they're great for when you initially practice because they are a little bit easier. This looks like a typical question which requires vectors. They could ask this in GCSE, they really could. Okay, so P is at 2, 3. They definitely ask this kind of question in, what do you call it, the level 2 AQA further maths. Q is an 8 minus 3. So what I do, if I want to split this in a ratio of 1 to 2, which is roughly like that, is I work out the vector PQ, and the vector PQ is just how we get from P to Q. It's clearly 6 minus 6. Unless I've misread that. Yeah, I'm going back to the original question, checking that out. So 1/3 of PQ, because that's all I really want to go, is going to be 2 minus 2. So I now know that when PQ is 6 minus 6, 1/3 of PQ is 2 minus 2. Now that's not the final coordinate. You obviously have to add that onto the end of this because P is at 2, 3. We're essentially going up to P and then we're moving from P to Q. Oh yeah. Sorry, yeah, 1/3 of PQ because we're looking for this point. Let's call it P dash. And so I hope you can see you just need to do 2, 3 plus 2 minus 2, and that gives you 4, 1. So it's D, yeah? Yeah, essentially what I've done is OP there, which is 2, 3, and I've added PQ onto the end, which is 2 minus 2, and therefore I've got OQ as a coordinate, which is 4, 1. Yeah? Okay, right, so that was nice and easy. Okay, next one. Next one looked pretty nice to me as well. I mean, this is just a typical function transformation question. There's nothing weird about this either. I think they misjudged the difficulty on this first specimen papers. Like they really did. They should have made them harder. Okay, so this is f of x. So what does f of x plus 1 look like? It looks like, of course, move 1 back to the left. So it's now going to be going through minus 1, something like that, yeah? Okay, what about if I then do that? Well, that's actually a reflection. What essentially that is the same as doing is putting the minus on this side, and therefore it's where the y coordinates have gone from positive to negative, which is a reflection in the x-axis. Therefore, I think the answer's A, because it'll have to look like that's being reflected in the x-axis, and that looks like A to me. Yeah. Yeah, absolutely. So I'm going to say A for that one. So what we got so far? D, A. I'll check these at the end because I haven't done these actually. I'm doing them all again because I've left my notes at home. Sorry, at school. I took them in. I had my first day of school back today, and so yeah. So let's see how we go. Which of the following numbers is the largest in value? Okay, so tan of 5 pi over 4 is the same as tan of pi over 4, yeah? And that's just because you can always add a pi in radians, or 180 degrees, to any tan thing, because tan repeats every 180 degrees. And tan of pi over 4 is 1, because it's tan of 45 degrees, yeah? Okay, so that's 1. What about sine squared of 5 pi over 4? Well, I'm looking for the largest, yeah? And I'm in a rush because I'm doing the short questions and I need as much time as possible on the much harder, longer questions in math. Rule this one out straight away, because it can't be as big as that, yeah? Well, at most, it would be equal to 1, because sine, remember, always oscillates between 1 and minus 1. So therefore, sine squared would always oscillate between 0 and 1, and therefore, at most, it could be 1. And no, it's not 1, because sine of 5 pi over 4 is the same as, well, it's like minus 1 over root 2, square it, you get up half. So it's definitely not that one. But anyway, it's these two. We're looking for the largest, remember, so don't spend too much time on that. Okay, log base 10 of 5 pi over 4. I suppose it's about time we roughly worked out what 5 pi over 4 is. It's 1.25 times 3.14, isn't it? Well, I mean, what is that roughly? A quarter of pi plus pi. Yeah, should I have it as a decimal? Well, let's have a look. Like, let's actually write it down. Let's give a rough guess. Like roughly 4. Yeah, I'm thinking that's roughly 4, because 0.75 is a quarter of 3. Add it on, but like it's going to be slightly more than that. It's roughly 4, just under 4, just over 4, something like that. So we've got log base 10 of 4 and log base 2 of 4. Which one out of these is bigger? Well, this is saying what do you need to put 10 to the power of to get to 4, and I can tell you it's definitely going to be like a square root or something like that, and so it's going to be equal to like a half, because we're looking for powers here. What do you need to put 10 to the power of to get to 4? Like roughly a half, slightly more than that, I guess. And then what do you need to put this to the power of? Well, that's 2. So I'm going for D here. I think that will be the biggest, because that basically equals, roughly speaking, 2. Okay, what about D? Ooh, this is linear programming. This used to be part of the decision maths. Well, it still is, I think. I haven't taught it in a while because we stopped doing decision maths, but earlier in my career I used to teach this every year. It kind of... Does it come up in anything else? Do they put it in level 2 AQA now? Little things like this? I don't know. I can't remember. Okay, but what I'm going to do this is I'm going to say, okay, let's hope it's 9. Yeah, and if this was 9, let's work out the conditions on x. So if this was 18 is less than or equal to, I've done 2 times 9 there, 23 minus, oh, why am I doing that? Let me just, so I've got 18 here. I'm just plugging in x is 9 to see what conditions it gives me. Then 3y would be less than or equal to 5, and so y would be less than or equal to 5/3. I'm seeing if this leads to any contradictions, basically, when I plug x in as 9. Okay, if I've got 11, because 9 plus 2 is 11, is less than or equal to 3y, and then I've got y is greater than or equal to 11 over 3. Can you see a contradiction there? Y is less than or equal to 5/3, and it's got to be greater than or equal to 11 over 3, because this must work in all the equations. You should be able to find a pair of values, x and y, that satisfy this. Well, y can't be less than that and bigger than this, so it ain't 9, yeah? And I picked the biggest one first just to see if I could, because if it was 9, then we're good, because it's the largest possible value. Let's try 8. Okay, we've got 16, that's going to leave 3y is less than or equal to 7, and so y is less than or equal to 7/3. But for this second one, we've now got 10. Y is greater than or equal to 10 over 3. That isn't possible, is it? It can't be less than or equal to 7/3 and greater than or equal to 10/3. That doesn't make any sense. So let's try 7. Okay, what we got here, 14 up to 23, so y is less than or equal to 3 there, because that's a 14. Take it off a 23, you've got 9 on this side, divide by 3. Here you're going to have a 9, and we're going to have y is greater than or equal to 3. That's okay. Y can be less than or equal to 3 and greater than or equal to 3, because y equals 3 is okay with that. Yeah. Now what about the last one? Let's just check if x is 7, which gives you 28 on this side, and y is 3, which gives you 10 on this side. Is that okay? Does that work? Yes, it does. So the answer is 7, because we can find a pair of values which works in all three inequalities. Okay, E. This looks like an interesting one. What have we got here? We've got sine x. Sorry. Let me stop rushing. Is equal to arc cos of a half. Well, I suppose it's best that we actually work out what inverse cos of a half is, yeah? And inverse cos of a half, well, inverse sine of a half is 30 degrees, or pi over 6, so inverse cos of a half is 60 degrees, or pi over 3. Or, I always point out, whenever you do an inverse sine, inverse cos, or inverse tan in maths, you get more than one answer. Now, if you ignored this answer, I think you probably would have been okay, because with cos, when you do when you're doing your cast diagram, or if you just do 2 pi minus the answer as I do, you're going to get 5 pi over 3. That is actually larger than 1, yeah, and so that's okay. And actually, hang on a second, pi over 3, because pi is 3.1415, that's larger than 1. And so, and the other answers, you're going to get a minus pi over 3, which is larger than, more negative than minus 1. We're going to get no solutions for this. So the answer is A. The reason we're going to get no solutions is you've got sine x equals 1 and a bit, like 1.07, or what is it, 3.14, sorry, 1.05, something like that, roughly speaking, and that's impossible, so no solutions. A. Can I just quickly, for my own sake, write down my answers there, just so I can check them? D, D, B, A. Have I done them all? Sorry, D, A, D, B, A. Okay. D, A, D, B, A, just so I can write on the screen. Okay, thanks for listening, and look out for the next video for the last 5 questions. Bye-bye.